Let's do some examples of how we will use the unit circle angles and our special triangles to find the sine, cosine, and tangent or other trigonometric functions of angles that are not in the first quadrant but are in quadrants 2, 3, and 4. So we want to find the sine of 150 degrees. There's going to be the same couple of steps that we're going to go through to do this every time. Number one, you have to draw the angle in the proper quadrant. 150 degrees is between 90 degrees and 180. That's a quadrant 2 angle. Next, we have to find the reference angle. So we're going to drop a perpendicular and we need to find this little angle here, recognizing that this bigger angle is 150 degrees. So we're going to take 180 minus 150. That gives us a 30-degree reference angle. So this angle right here is 30 degrees. That means I have a 30, 60, 90 triangle, and I can label the sides as 1, 2, square root of 3. 1, 2, square root of 3. The next step will always be watch your pluses and minuses. So we know going up is a positive direction, but going to the left is a negative direction. So this square root of 3 needs to be a negative number. Now we're going to say, what is the sine of 150? Well, that's the sine of this 30-degree angle. What is the sine? So opposite over hypotenuse, the sine of 150 degrees is going to be positive 1/2. That jives with our all students take calculus. We know sine in the second quadrant should be the one that is positive. So our answer is correct. All right, let's try the cosine of negative 60 degrees. So first we draw our angle. Remember, negative means we go in a clockwise direction. So we're going to go 60 degrees this direction, which means we automatically have our reference angle. That's nice. So this is again a 1, 2, square root of 3 triangle, but 60 is the biggest angle. So the square root of 3 goes over here. 1 will be opposite the 30-degree angle, which is here, and 2 is here. When we're going to the right, that's positive, so the 1 will be positive. Going down is negative, so the square root of 3 will be negative. Now all we have to do to find the cosine of negative 60 degrees is find adjacent over hypotenuse. Cosine of 60 degrees will be 1/2. So you can see we're just going to repeat this process. Draw the angle, find the reference angle, label the sides, watch the signs, and then use SOHCAHTOA. Let's try 510 degrees. Now, immediately you should see, 510 degrees, that's bigger than 360. So the first thing we need to do is find a coterminal angle. So 510 minus 360, that is 150 degrees. So the tangent of 510 will be like taking the tangent of 150 degrees. And that is the angle we need to draw. Okay, 150 degrees, that's in our second quadrant. We're going to drop our perpendicular. Here's 150 degrees. 180 minus 150 is 30 degrees. So our reference angle, which is going to be here, is 30 degrees. Thus, we have a 30, 60, 90 triangle. Opposite of the 30 is a 1. 2 is the hypotenuse. Square root of 3 is the adjacent. And going up is positive, so the 1 is positive. The square root of 3 is the adjacent. That'll be a negative because it is going to the left. Now we need to say, what is the tangent of this reference angle? TOA, opposite over adjacent. Well, that's 1 over negative square root of 3, or the tangent will be negative square root of 3 over 3. Is tangent supposed to be negative in the second quadrant? Well, yes, only sine is positive, so tangent should have been negative. We're probably on the right track. All right, let's do one that is in radian measure. So 3 pi over 4, 4 minus 1 is 3. That puts us in the -1 quadrant, or in second quadrant. And remember, reference angles for radians are easy. This is a pi over 4 angle. That tells me this is a 45, 45, 90 triangle, and my sides will be labeled 1, 1 squared at 2. Now we're going to check for the pluses and minuses. Going up is positive, so this one will be positive, but going left is negative, so this one will be negative. Now we want to find the sine of that reference angle. Well, what is the sine? So opposite over hypotenuse. That's 1 over square root of 2. Rationalize it, 2 square root of 2 over 2. It's positive, but again, sine is positive in the second quadrant. This is what we were supposed to have. All right, 2 more, and then we will jump to a different video. So let's try tangent of 4 pi over 3. 4 pi over 3, well, that's a plus 1. That puts us down here in this quadrant. So we're going to connect, and remember, that means that our reference angle is pi over 3 since our denominator was 3. Okay, pi over 3, that's like 60 degrees. So this is a 30, 60, 90 triangle. So I'm going to say, okay, just to make things easier on me, this is a 60-degree angle. That's the bigger angle. So the square root of 3 goes here, the 1 goes here, and the 2 goes here. But the 1 is to the left, so it's negative. The square root of 3 is down, so it's negative. And now we find the tangent to negative square root of 3 over negative 1. And this instance will give us a positive square root of 3. Now, don't get lulled into the fact that, oh, it's always going to be positive. No, you have to check every time. If we would have asked for the cosine in this quadrant, that would have been a negative answer. So you need to always label your triangles and check your pluses and minuses. All right, one more. Let's do one that's not one of our big three. Let's do secant of 11 pi over 6. So first of all, 11 pi over 6, that's a 2 n plus 1 or 2n minus 1, so we're in the fourth quadrant. 11 pi over 6, that means my reference angle is pi over 6, and I'm just going to remember, okay, they switch. Pi over 6, that's 30 degrees. So I'm going to go ahead and label this with a 30 degrees. And that tells me that this is a 1, 2 square root of 3 angle. The square root of 3 is positive because this is the positive x, but the 1 is negative because this is the negative side. And now, okay, secant, isn't that the flip of cosine? So first I need to find what is the cosine of 11 pi over 6. Adjacent over hypotenuse. That's square root of 3 over 2. So the secant is the reciprocal of that, 2 over square root of 3, or 2 square root of 3 over 3 for my final answer.